All right, here's a question about transformations. Like section 2.4, 2.5, whatever it is. But looking at transformations and looking at just a base function of y equals x squared versus y equals x minus 3 squared. Just according to the format that they have, where they have a and then bx minus c plus d, well this is f. So where things are at, so both a and d affect y values. So d you add or subtract y values, a you multiply, you multiply y values, and then b and c both affect x values. B, you divide all the x's by whatever b is, and c, you add or subtract all the x values by whatever c is. So in this case here, this is a c value, and just according to the plus minus kind of thing, if this sign here is minus, that tells me that the graph moves to the right by 3 units, compared to this graph over here. Now, so if I was to take a look at the graphs, y equals x squared would look like this, and this one over here, if it moved to the right 3, it would be over there. So the graph would look the same, have the same shape, it's just that this one is moved 3 to the right. Now sometimes you might question that and just say, well, let's plug in some values for x and y and see if that actually is true. So let's do it for this one. Let's do an x and a y of the graph, and we'll just plug some numbers in. So if x is 0, y is 0. If x is 1, 1 squared is 1. If x is a negative 1 all squared again is a positive 1. If x is 2, 2 squared is 4. If x is negative 2, again remember you have to put that in brackets when you square it, it also comes to a positive 4. So those points 0, 0 would be there. 1 and 1 would be right there. Or negative 1 and 1 would be right there. 2 and 4, negative 2 and positive 4. So there's sort of what the graph would look like. Similarly, we could do it with this one. So if I plug in, let's plug in the same numbers. So 0, 1, negative 1, 2, and negative 2. So if I put a 0 in here, it'd be 0 minus 3 is a negative 3, and negative 3 all squared is a positive 9. Okay, put a 1 in. 1 minus 3 is a negative 2. Negative 2 squared is a positive 4. Put in a negative 1. Negative 1 minus 3 is a negative 4 squared is a positive 16. Okay, put a 2 in. 2 take away 3 is a negative 1. Negative 1 squared is positive 1. Put a negative 2 in. Negative 2 minus 3, negative 5, all squared is 25. Okay, and then if I go up here to look at where those points are, so 0 and 9, so 0 and 9, so this here must be crossing at 9. 1 and 4, 1 and 4 right there. Negative 1, so negative 1's over here, it's got to be quite a bit higher up there, so 16-ish. 2, so if I go over 2, this should be up to 1. Okay, negative 2, if I put a negative 2, it's going to be really high, positive 25. I didn't put that in, but how about we put in 3? So put in 3 in. 3 minus 3 is 0. 0 squared would still be 0. So that would be that point right there. I'm betting if you put in a 4, you're going to get that point right there. Put in a 4. 4 take away 3 is 1. 1 squared is 1. Yeah, that would be that point. Okay? Hopefully that gives you a little bit of background or help on just how graphically this whole idea of the transformation means or looks like. Main thing with transformation, like I said before, is identifying what slot each of those numbers is in, and then based on that, know how that affects the graph.